This lesson here is pretty much an identical lesson to the one we just finished doing with where your angle for cosine was the sum of two or a difference of two. So this lesson just shows you what to do. Of course, we always probably, if you wondered if there was one for sine and one for tangent, there is. The sine one, now remember, let me write up the cosine one for just a second. Cosine of alpha plus or minus beta was cosine of the first, cosine of the second, and opposite, so minus plus, sine of the first, sine of the second. So it went cosine, cosine, sine, sine. Well, the sine one actually alternates. It starts with sine, then goes sine, cosine, then cosine, sine. It's always the first angle, second angle, first angle, second angle. It's just now it kind of alternates between sine and cosine, then cosine and sine. And what's in the middle is actually your same. If it was a plus on the left, it's a plus on the right. Okay. Tangent's a little bit different. On the top, it uses the same sign as I showed you guys. It's just tangent of the first and tangent of the second. And the bottom is just one with the opposite sign of the product of the two. Okay, so really just getting practice was going to help you out with understanding these two. Well, let's go back. Let's start out with our first example. We want to use all those identities pretty much that we know from square one. The square one being cosine squared and sine squared equals 1. And we want to combine it with everything that we've known thus far. We want to, the first problem asks us to find sine of x plus 5 pi over 4. So I only have one identity to find this. It's going to be sine of the first times cosine of the second. Same, so plus cosine of the first times sine of the second. And that's just knowing the formula and getting practice with it. Okay? There's some pieces of information that I already know in here. I don't know sine of x. We're going to find that. I know that cosine of 5 pi over 4, so my x value at 5 pi over 4, we're down there in quadrant 3, so it's going to be negative square root of 2 over 2. Cosine x. Do I know cosine x? Going to a piece of information they've given us, it says that secant is negative 25 over 24, and I know that secant is the reciprocal of cosine. So really cosine is the reciprocal of that value, which is negative 24 over 25. So I do know cosine of x is actually a negative 24 over 25. And then my y value at 5 pi over 4 in quadrant 3 is a negative square root of 2 over 2. So out of all of this, all I really have to do is find my sine of x, and then I can fill in the rest and we can call this done. So let's find that sine of x. Well, I know that sine squared x is 1 minus cosine squared x. Well, cosine x is negative 24 over 25. And if I'm going to square it, so it's going to be 1 minus 24 squared and 25 squared. 24 squared is, 576. And 25 squared is 625. So if we kind of combine these together, 625 and minus 576 is 49 over 625. And remember, all of this is sine squared equals. So we're going to take a square root. I need to leave myself a lot more room next time, but equals plus or minus the square root of 49, which is 7, and the square root of 625, which is 25. And our angle x is in quadrant 3, so my y value in quadrant 3 should be negative because we're below the x-axis. So we're going to write it as a negative 7 over 25. Okay, so we're going to go put that back in the main equation. So sine of x is a negative 7/25. Then we have that negative square root of 2 over 2 we already found. And we have the negative 24 over 25 and the negative square root of 2 over 2. So all I have to do is combine some information going across the top of each of these fractions real quick, and then we can finally get our final answer. So in that first one, we have a negative times a negative, which will come out positive. And in the right, we also have a negative times a negative that will come out positive. So finishing this up, it'll be 7 square roots of 2 over 50. On the right, it'll also be a positive 24 square roots of 2 over 50. Common denominator of 50 7 square roots of 2 and 24 square roots of 2 looks like 31 square roots of 2. Box that one up and we can call it done. Alright, let's go to example B. We want to find cosecant of t minus 3 pi over 2. Okay, I don't know cosecant, but I know that cosecant is 1 over sine. So it's 1 over sine of t minus 3 pi over 2. So it's 1 over the sine of the first times cosine of the second minus cosine of the first times sine of the second. Okay, and plugging in some information I know, going back to the original problem, it tells me that cosecant is 5/3. So because of that, I know that sine, which is the reciprocal of cosecant, is 3/5. So this is 3/5 for sine of t, replacing that one. The x value at 3 pi over 2, down there on the y-axis down below, is actually 0. The cosine of t, and then the y value down there at 3 pi over 2, which is -1. So that's actually going to go all away, and this is what we're looking at just left to find, is 1 over the cosine of t. So if I know the sine of t, can I get the cosine of t by just knowing the sine of t? Which of course I can, which we've done that so many times before. So let's just do it one more time. So let me see if I can come over here, or let me just scroll down to this other side and we're going to find this out. Okay, I know, and I'll erase it later, but sine squared t is the same thing as 1 minus cosine squared t, or cosine squared t is 1 minus sine squared t. Pretty much need to use this one because I'm actually trying to find cosine. Okay, so cosine squared t is 1 minus my sine value, which we decided right here. Sine value is 3/5. Okay, so 1 minus 3/5 squared. So 1 minus 9 over 25, and 25 minus 9 is 16 over 25. We want to take a square root of both sides and make sure we do plus or minus. So cosine of t is plus or minus 4/5. And cosine, if we go back to our problem real quick, our angle is in quadrant 2, and cosine in quadrant 2 is negative. So cosine of t should be a -4/5. Okay, now this is honestly my mistake in the sense of I did not plan for plenty of room to do these examples, but when it comes time to do these problems on your test, I really need to see all this side work. So don't just expect to just kind of do it on the side and erase it and call it done. I really need to see all of your side work, okay? So just keep that in mind. I'm going to give you plenty of room on the test. It's just, for some reason, I don't know what I was thinking. I just didn't do it on the notes. So cosine is going to be -4/5. All right, so let's remember that. Coming back up here to the problem just so we can wrap this up. So this is going to be 1 over a -4/5, and 1 divided by any fraction is the same thing as that reciprocal, and there's our answer right there. So the cosecant of t minus 3 pi over 2 is going to be a -5/4. Okay, so moving on to our next example. Let's see if I even allow myself any better room. We'll see. But in a nutshell, if you ever wonder what do you have to show on your test, if you see me doing it here on this board, that's what I'm planning on grading on. So if you see me do side work, incorporate side work. If you see me, I'm using this this formula to replace this, or if I'm using this formula to do this, write all that down. It doesn't hurt. Okay, so when in doubt, write it down. In this problem, it asks us to find tangent of t plus 5 pi over 6. Well, it's the first time we're going to do tangent expansion. And tangent says it's going to be the tangent of the first, same sign, tangent of the second, over 1 opposite minus tangent of the first times tangent of the second. Okay, so let's think about this for a second. What is the tangent of 5 pi over 6? At 5 pi over 6, our coordinate is the negative square root of 3 over 2, 1/2. Okay, so if I take the ratio of a y value divided by the x value, or multiplied by that reciprocal, you will see that it's the negative 1 over the square root of 3. Okay, I might just work with that right now before I rationalize that denominator, mainly because we never know what's going to happen. I could rationalize it, put it in, then have to re-rationalize it later. So let's just give ourselves the benefit of the doubt just in case. Okay, so I know that everywhere I see tangent of 5 pi over 6, I'm going to write a negative 1 over the square root of 3. Okay, and then 1, see if that's going to be a negative 1 over the square root of 3, and then there's a negative out front, we can change that to a positive, and I can say tangent of t and 1 over the square root of 3. Okay, so if I can just find tangent of t, we'll plug it in, and then we can call this one done. So tangent of t, the only other piece of information they give me is sine. So can I get tangent when I know sine? There's probably, honestly, about maybe 2 or 3 different ways of where you can get tangent when you know sine. The first piece that's coming to my mind is the fact of, maybe I'll start this here and I'll erase this here in a second, but here's some of your side work. Okay, I know that one identity that says that tangent squared, in this case we'll call it t, plus 1 is equal to secant squared t. I know that one. Let's see, I also know that cotangent squared t plus 1 is equal to cosecant squared t. So the question is, according to the information that I have sine, and sine will give me cosecant by taking the reciprocal, and then this will solve for cotangent, take the reciprocal of that, and I got tangent. So I don't know, let's try that one. So we don't really need that one, we're going to go with the second one. So cotangent squared t plus 1 is cosecant squared, and cosecant's reciprocal, so we're going to write this as 13 over 12 squared. Okay, so cotangent squared t is going to be 169 over 144 minus 1 by the time I move that 1 over. Okay, so cotangent squared t is 169 and 144. The difference there is 25 over 144. So cotangent t is going to be plus or minus the square root of 5 over 12. Hopefully you all are going through these a lot faster and faster and faster. Okay, in quadrant 2, cotangent is definitely negative. So cotangent of t is a negative 5/12. Therefore, tangent of t is a negative 12/5. Okay, so that's what we want right there, is that tangent of t is a negative 12/5. So we have a negative 12/5 for that tangent right there, the very first one right there. Then we have a minus 1 over the square root of 3. Then I have 1 plus a negative 12/5 times 1 over the square root of 3. Alright, and working on this some more just so we can hopefully clean this up a little better. Let's see, the top's not looking so fun, but we have negative 12 over 5 minus 1 over the square root of 3. And then down here in the denominator we have 1 minus 12 over 5 square roots of 3. Honestly, from here it's just a matter of kind of cleaning this up and trying to do algebra to make this look good. This is looking really gross right now. I'm not sure if there's really anything much we can do. We can combine the two terms in the denominator as 5 square roots of 3 minus 12 over 5 square roots of 3. Oh guys, honestly at this point I'm trying to figure out how much. I'd picked a fun example for you guys to try. At this point I'm almost tempted just to say, hey, you get to this step, especially with this tangent one, why don't we just call that done, because that's going to get gross after a while. The key here is I want to test to make sure you understand how to do the tangent expansion and then how to use other identities to help plug in So let's just do that. I'll give you guys some grace period on some of this. And you're very welcome.